Hi, this is the lab for Soaring Straws. The gravitational potential energy of an object depends on how far it can fall and can be increased by raising the object to a greater height. In this lab, I've made a launcher by cutting a rubber band, taping it across the open ends of a toilet paper tube. I then taped two straws together at one end, and at the other end, I marked 1 centimeter increments on one of the straws. I held the launcher in one hand with my fingers over the rubber band end, placed the rocket in the launcher, and then rested on the rubber band. I pulled down and measured a stretch by the marks on the straw. In the first video, I pulled the straw down 3 centimeters. Let's take a look at that video now. You'll notice on the straws the markings. I put it into the toilet paper tube, line it up to the bottom of the ruler, and then I pull down 3 centimeters and then launch the straw. I did that 3 times. Underneath this video, you'll see my trials for 1, 2, and 3. The first time, the straw rose up to 50 centimeters. The second time I pulled it, the straw went 15 centimeters. And the third time I pulled the straw, it went to 36 centimeters. For the next video, I took the straw, and this time I pulled it down 4 centimeters. I pulled down on the straw, measuring 4 centimeters, and released. In my first trial, the straw went up to 72 centimeters. In the second trial, my straw rose to 55 centimeters. And in my third trial, the straw rose to 42 centimeters. Please enter that data into the data sheet from your lab. When entering that data, please make sure to convert your height in centimeters to meters. Your data table asks you to find the average height. In order to find the average height for each trial, you'll need to add up the 3 different trial heights and then divide by 3. Remember to make sure to convert your measurements from centimeters to meters by moving your decimal 2 places to the left. You are also asked to find the gravitational potential energy. Gravitational potential energy is measured in joules. Gravitational potential energy equals the weight in newtons times the height in meters. To get the weight, you must convert the grams to newtons by multiplying the number of grams that the straw weighs by 0.0098 newtons per gram. Let's take a look at the Think It Over section. Number 1 asks you to graph the gravitational potential energy versus the amount of stretch. Go ahead and create a graph on paper, take a picture of it, and include it with your lab. Number 2, in this experiment, what measurement is related to elastic potential energy? Is it the measurement I took when I stretched the rubber band, or is it the measurement I took for the height that the straw rose to? In the second part of that question, it says, what relationship between the elastic potential energy of the rubber band and the gravitational potential energy of the rocket does your graph show? So what happens when the elastic potential energy increases? How does that affect the gravitational potential energy? When you are finished with the lab, make sure to submit it along with your graph. Thank you.